Hello guys, today we are studying this project here. Okay, this is the classification, sorry. Today we are studying this project, this face recognition using entropy weighted patch PCA array under variation of lightning condition from a single sample image per person. Okay, and please visit my website for the code. Okay, and you can email me at this mail ID or at this Gmail ID, and let me just show you the paper which we are looking at, which basically we are implementing. This is the paper we are implementing today. Okay, let me just give you the brief description about the paper. Basically in this paper we are using the patch PCA array, that is the principal component analysis. Okay, we are dividing the image into patches. Say I divide the image into 100 patches, and then I'm applying the PCA on each patch, and then I'm recognizing multiple faces of a single person from a single photo, and the multiple faces are under different lighting conditions. Okay, so of course I'm not getting the 100% accuracy here, but still the accuracy is very good. Okay, it's like 80-90% accuracy. I have not calculated it yet, but you can, it's not that difficult. Okay, so let me just switch back to the code, and this is the mathematics. Okay, so basically the purpose of R is classification here. This is the classification part. This is the CM contribution map. I'm just finding out the PPCAA patch PCA array principal component analysis of the query image and the model image, and then I'm weighing the subtraction of both of them by the CM. CM is the contribution map, okay, of the query image. Okay, so let me just switch back to the this program. This is the mean patch. Okay, I'm just suggesting you, I'm not commanding you, I'm just advising you. First, please read the paper before implementing or before understanding, before you try to understand this program. Okay, because it could be a messy one. Okay, so this is a simple function. In this we will find the mean patch. Basically we divide the whole image into multiple patches. Okay, patch size is 10, so 10 by 10, we are taking 10 by 10. Okay, and the mean patch is this. Okay, this is the function, and I'm taking these outputs: mean patch I, count, patch size IM. Okay, so these are the output I'm taking here. Okay, so next we will move on to PPCA. Okay, this PPCAA, in this I'm just subtracting the mean patch from all the patches of the image. This is like IM, and I took the IM as output in my previous program, so I'm calling it here. Okay, this is the normalized patch I'm getting. Here. Okay, so as I am applying the PCA principal component analysis, okay, so I have to find the covariance matrix. Okay, I'm finding the covariance matrix, and then I'm finding the eigenvectors and eigenvalues, as you can see. Okay, as we are going forward, and then I'm storing the PPCA array here. Okay, this is the PPCA array here, and I'm taking it as the output. Okay, so let me go up here. This is my PPCA array. Okay, so just this is my PPCA array. Okay, and then I have to find the contribution map. Here, contribution map is, let me just tell you what we are doing here in the contribution map. Let me just open the paper here. Okay, this is the contribution map. This, I'm finding this formula for all the patches in the image. Okay, so yeah, we are finding this, and then we will find the classification part. This, it's simple if you try it once. This is the CM part. Okay, so this is just a mess I have created, but not to be mentioned here. So that's the CM part, and I'm taking the output new and normalized entropy map. I'm gonna use it in my main function. That's the classification function. Okay, so here we are, classification. This is the function we are gonna run. Okay, so this is my query image. Okay, and let me just tell you about my database first. Okay, this is my database. This is my database. I am using the database of 5 subjects. Okay, and each subject has multiple images. And this is the Yale database. I just took some part of Yale database, so not to mention here. And I put the model images here in the open part. These are my model images, and I'm picking the model images from this folder, from the project November 2017 folder. Okay, and this is my database faces. These are my query images. Okay, I can pick any image from here. Okay, let me just take S3 first image. Okay, it's I'm taking the first image. Okay, so this is the this is my query image, and I'm checking out all the model subject. Basically, I mentioned it here. This is the 5 images I am picking up. Okay, so I just ran this program, and you will find out that I am gonna run this. Okay, so you won't be having any problem. You will see it for yourself. Okay, so run. Okay, so I think we need to wait here. Okay, waiting and waiting. Okay, so it's taking longer than I thought, I guess. Okay, here we are. This is the query image, this is the EMAP of query image, and this is the CMAP of query image, and this is the matched image. So what does it mean? It means that this query image matches with this. Okay, so I think we are on the correct path here. Okay, so let me just close it, and let me take another image from my database. Okay, so let me take this, copy, editor window, paste. So let me run it again. I think this time it's little bit faster. It's gonna be a little bit faster because I'm running it the second time. Although it doesn't make any difference, but still it will be faster. I think I'm talking too much, but okay, it's taking its time. So I think we can browse here some variables. Okay, this here. Okay, so as we can see here, this is my query image and this is the matched image. Okay, so the query image here is the lightning condition are somewhat different, but still it matches with the database image. Okay, this is where the accuracy comes. As long as the lightning condition are up to some threshold, the image matches. But when the lightning crosses a threshold, the image won't match. But still, this algorithm has good accuracy. Okay, over a certain types of images or over a certain lightning condition. Okay, you can, and this is just for the glimpse of it, and I would like to tell you here this classification part. Okay, I'm finding it here, the sum here. Okay, this test P. How I am finding this? I'm finding it here sum. Okay, you can find here something else as well. Okay, it's not like you have to find the sum. You can use some other parameter as well. Okay, this is the main part. This is where the research work comes in handy. Okay, you can find it here mean, median, mode, or you can apply some other algorithm. Okay, to identify to what to do with the distance variable. Okay, I found the distance variable in that in the line number 30. Okay, but what I am doing with this distance variable, I am just finding the sum. Okay, this is just for glimpse of the face recognition part. If you do something else, something great, you will increase the accuracy of this algorithm. Okay, that's enough for now. Okay, so I guess this is where the video should end. But before I end this, okay, let me just tell you one more thing. Please guys, please and girls, like, share and subscribe. Okay, and I guess goodbye. No, sorry, I don't like goodbyes. I guess it's just bye.